English language permits, because it's not surprising, because the Gujarati navigators went to Zanzibar, Tanzania much before Europeans went. Much before Europeans went. Hundreds, thousands, at least 1,000 years ago. He has settlements there. So naturally their language had to be so smart to be able to deal with that kind of process when they had no other tools. So please understand, language can compensate for lack of tools. So if you do not have tools, then language compensates for it to some extent by making sense of it. So I can't deal with that phenomena, but I can classify it. The moment I classify it, I have a strategy. I can have a strategy. I may not have a strategy. I can have a strategy. So when you look at theory of rasa in Indian classical tradition, there are different kinds of rasas. There are different kinds of expression of feelings, right? Shrangar, Vibhas, Rodra. There are different rasas. Anger, Vibhas, what will it be? Very fearful, huh? Shrangar, beautiful, ornamental. Hasya. The whole range. In other words, yes. So the theory of rasa, the theory of different feelings or attributes of feelings, all this emerges from what one of the texts which we will discuss in one of the sessions, Sankhya. Sankhya Yoga is a treatise on taxonomy. Gita also has a section on Sankhya. This is a theory, maybe 3,000, 5,000 years ago, we don't know, around that time, where, for example, if you want to understand something, we will discuss in detail tomorrow, but I will just quickly mention, Gun, Karma, Prakar, Sabhav, Vritti. 5 things you need to know about any phenomena. What is a Guna? Attribute. Karma, action. Prakar, types. Sabhav, behavior. Vritti, tendency. Wonderful way, isn't it? 5-fold classification, 5-fold matrix to classify things. So what is the attribute of it? What is the behavior of it? What is the type? What are the types of it? What are the actions? What are the impacts of it or actions of it? And what are the tendencies of it? So we know that water has a tendency to move to the lower point. That is tendency. We know that water can become different forms. Water can be ice, water can be vapor. We know that water it gives coolness when we touch it. Sabhav. Thanda lagta hai. It evaporates and gives cooling. That is sabhav. Action, it dissolves. Erases, dissolves. It has a tendency to assimilate. So gun, karma, prakar, sabhav, vritti. So we can find out the properties of any phenomena by looking at these. So the treatise which our thinkers, philosophers evolved is called Sankhya. Sankhya means statistics, basically. But statistics, the science of statistics evolved later, but the phenomena of classification evolved first. So if you have good classification system, then you can deal with variability much better. That's the point, because you have now categories. So we will look at later when we look at innovations, one of the thing is, and you will see in business policy also, is it a category creator? Can a technology create a category, new category? The moment you create a new category in the mind space of a consumer, you create a new way of situating yourself. So category creating technologies, category creating solutions, category creating phenomena is one of the most lasting phenomena that can emerge. And therefore, those who are very smart in terms of managing knowledge and variability in the system do not want to mix their things with the existing categories. They want to create a new category. And that is one of the challenges. So we'll come back to that. What else can we do for variability? There are many more ways to deal with variability.
Is forgetting the same as selective perception?
That is same, but Gödel is a famous mathematician. Quote Gödel. There is a Gödel theorem. Huh? But what is one of the very basic tool of reducing variability is understanding the usage. No, that is correct, but how will we reduce the variability? That is the purpose. The purpose is to understand. To understand, we have to reduce the variability. So what should I do? So what is the tool for that? You're right. That's the purpose. So Gödel gave one yardstick to us. Gödel, the famous mathematician, gave one yardstick. He said, what happened when Bertrand Russell and Whitehead claimed that all provable theorems have been proved? He said that is the proof against it. He made a very interesting point. He said at least one assumption should be made outside the framework in which we are trying to prove a proposition. In other words, that assumption you cannot test in the same framework. You have to do it outside that framework. It's very interesting. In our Indian philosophy, if you do not believe in infinity, you must assume that there is something called infinity so that you can explain finite. You don't have to believe in God, but you have to believe in infinity. You can be atheist, completely atheist, but you cannot deny the fact that there must be something which is infinite to be able to explain the finite. That you cannot test. So one of the ways in which we make sense about variability is assumptions. We make assumptions. Of course, there are tools to test them, but assumptions are one of the very important ways in which we deal with variability. We assume other thing equal, change in x leads to change in y. Now this assumption, ceteris paribus assumption, is a huge assumption without which a lot of analysis would not have been possible if we did not accept ceteris paribus. Correct? Because other things are not same, other things that do not remain constant. We know that it doesn't remain constant, but we assume it. For the purpose of analysis, we assume it. So assumptions are one of the very important ways in which variability is dealt with. And these assumptions, there's a lot of debate on this. And let me tell you a small story. Friedman, one of the famous economists, said, I don't care whether assumptions of a theory are valid or not, so long as it does what it should. In other words, if a theory predicts well, to me that's a good theory. Samuelson, another economist, called it a very bad statement. He said, I will not touch a theory with a barge pole if the assumption on which the theory is based are not valid. This debate is called F-twist. It's called F-twist. F-twist. There is a famous paper by Alan Musgrave on F-twist untwisted, and Amartya Sen has also written on this. Those who are interested in knowing more about this should read in detail. But the point was that it has a politics underlying it. It has a very deep. It has deep implications on the way you organize yourself, the kind of society you create. Because if there are certain assumptions that you make, other things being equal, then you also assume that some people can keep other things as constant. It's a reflection of power. Correct? So if it will work, surely it will work for those who can keep other things as constant. That means who can control background risks. So assumptions have a very important role in dealing with variability. Almost any theory that you pick up will involve assumptions. Question is how realistic those assumptions are. And there are different kinds of assumptions. Assumptions which determine the domain, assumptions which determine the reliability, assumptions which determine the fluctuations, assumptions which determine the accuracy. So there are different kinds of assumptions. Not, I mean, one same assumption does not hold for all parameters, and you can therefore have different kinds of assumptions of a theory. Some may be violable and some may not be violable to have impact on the theory. But it is very important that to understand how assumptions, what else can we do for variability? Huh? Priorities, prioritization. Okay. What you can say is, I will not deal with all sources of variability, but I will deal with some sources of variability. So when you do any experiment in biology or physics or whatever, you prioritize certain kinds of variability. So when we design buildings as an architect, there are a lot of risks possible, isn't it? You don't provide for all risks. You look at the probability. So prioritization or probability? You calculate the probability of different kinds of risks, and then you decide which one. There is a very interesting paper by Barclay Hudson called as Watershed of Success and Failure. And he says, why are 5 engines in an aeroplane not safer than 3 engines? There is a concept in statistics called as Bayesian analysis. So he makes a Bayesian curve. Bayesian curve is very steep. And what he shows is that if you look at engines, for example, there are different components in an engine, and there is a possibility of error in each component. So when you calculate the total risk, you calculate the multiplication of the probabilities of each component. That is the risk of an engine. When you have 2 engines, you will calculate now the probability of engine going fail, 3. But after a while, the 4th engine doesn't give you more security, because it has reached that level of error that there is no additional security that you are getting. Now that leads us to another concept, which is redundancy. So how do we deal with variability? One of the ways in which we deal with variability is redundancy. So I keep one stepney. My experience shows me that the probability of a tire going puncture within the distance of another point where puncture can be repaired is X, and if I keep one stepney is enough. So most travelers keep one stepney. They don't keep 2. But the racing car people keep 2. Isn't it? They have 2 tires, though long distance travelers, and of course they have also relief vehicles and all of that. But the question is that if you look at the design of institutions, design of technology, design of institutions, you don't provide for very high redundancy, because redundancy has a cost. So what do you do to reduce redundancy? You can't keep everything in triplicate of quadruplicate, You can't keep some extra copies of everything in the house. So what do we do? What do we do in our home to reduce redundancy? How do we reduce redundancy? Huh? We need to be? No, but how do we reduce redundancy? There's the uncertainty, right? Variability means there's a variation in the phenomena. I can't predict it. So then there's uncertainty. So how do I deal with it? So I have to have some redundancy. How do I reduce redundancy? Because there's a cost to redundancy. I cannot afford to keep everything extra.